Good evening, everyone.
Good evening.
Hi.
Going.
Good. Need help with this week.
I know.
I see. Well, now we finally jumped into hypothesis testing. How did you feel so far?
It's like a alien language to me.
Oh, really? Okay, I see.
I was
how-
okay up until problem 3, and then I got lost. I didn't know what.
Okay.
Yeah, problem 3 was, I didn't even know what to do.
How about other students? Any ideas on problems such as problem 3 in homework 6?
I guess we all stuck over there.
Oh,
I don't know.
really? Okay.
How about Steven?
I gave it a
So
shot.
far?
I don't know if it's right. I gave it a try. I don't know, Jerry. It feels like the video lecture for problem 3 was, listening to the professor's concepts as I'm working through the problem. It just seems like it's similar, but the problems are asking to maybe take it a step a little further, which makes it sometimes hard to connect those dots. But I gave it a shot. I get the statistics file he provided. That spreadsheet's amazing. So I gave it my best effort.
Oh, I see. Well, great. How about other students? Did you run into any questions and problems when solving homework 6? How did Mark and Nora and Ruth find the homework to be like?
Yeah, just stuck on question 3.
Ah, really? Okay. So did all of you find problem 1 and 2 relatively easy and we can skip them? Any questions regarding problem 1 or 2?
My only question with problem 2 was if we were supposed to take it further.
Sorry, a favor?
Further, like,
Further,
so the question, yeah,
okay.
so it kind of ends with, if a person tests positive, what is the probability that he or she is actually infected? And then his videos go further into it, where it talks about what's the probability of someone being positive. And so then you take the false negative and the positive and you put them together. But that's not what the question's asking here. So I think my only question was, we weren't supposed to go further, right?
In terms of going further, you do need to calculate this like reverse probability because the question asks if a test shows positive, and what's the probability of actually getting COVID, right? So you do need to flip through the multiple probabilities calculated.
Okay. I mean, I have all my work, like the 7% to the 99 and then the 1%, and then the 93% of the negative to the 97% accurate and the 3% false negative. So I have all of that like shown. I just didn't know if you wanted like the overall rates too.
Overall rates of what?
Positive and negative.
Overall rates of positive or negative. So the overall rates of correctly identify.
Well, I can.
Yeah. How about you show me what you worked on so I can understand. Yeah, what I meant is that to address the question, that's the last sentence in problem 2, we do need to go over the Bayesian theorem of to flip the position of some probabilities to calculate the actual probabilities we want. That's when the test shows positive, how much percent or how much confidence we are sure that a person is infected, and vice versa. If That's basically
Okay.
the.
Can I share my screen with you real quick?
Oh, right. I need to enable it. I forgot. Yeah, now you can. So
Thanks.
let's see how we can use the Bayesian theorem to calculate some probabilities that's not directly, that's usually not directly shown. Wow, interesting. I like your chart.
Oh, thanks. But I just didn't know if you were looking for like more calculations than this.
How did you get 6? Oh, I see. Ah, okay. Yeah, well, wonderful work. Unfortunately, there's some further step you do need to take. You calculated for basically for cells of dividing the percentage into whether it's accurate or false positive, right? So this is a good starting point. We need to take advantage of what we have calculated here. Oh, wait. Let me see.
Because if the question is if a person tests positive, what
Mhm.
is the probability that she is actually infected? So 7%, it's 99% accurate. So out of the population, it's the infection rate would be 6.93
Okay.
if a person tests positive.
I guess it's because of the rounding you have. I have a different set of probabilities, but let me just make sure that I think you calculated reversely. Okay. So let me re-examine this. Okay, so we know the prevalence is 7%, and we know the false positive rate and the false negative rate. So that also gives us the true positive rate and the true negative rate. I see.
Did everyone else get the same answer I did?
I got something different.
Yeah, so let me.
I can stop sharing, someone else can share. I don't know what I did wrong.
So first, here you have. Let's take a look at the first row. So we know the prevalence, that's 7%. You got that right. And in terms of which percentage is accurate, we need to calculate the true positive rate, right? So unfortunately here, what you got here is not the true positive rate. So the relationship between a true positive rate and a false positive rate is not that they sum up to 1. So it might be not intuitive at this moment, but let's think about what a true positive rate means. A true positive rate is the probability when a person gets COVID, conditional on this, then how much percentage or how much chance do we have a positive test? Do you agree?
Can you repeat one more time? Sorry.
So on the first row, what we actually wanted to calculate is the true positive rate. The true positive rate is that conditional on a person is infected, that's 7% of possibility. If a person is infected already. What's the chance can we actually use the test to detect it? So you got here, right? The explanation for the true positive is the probability of having COVID and test positive. However, you do need to make a somewhat conditional probability. So that this first rule we have here is that conditional on having COVID, the probability of testing positive. But unfortunately, the calculation here was not correct. So as I said, this percentage accurate, which actually means this true positive rate should not be 1 minus false negative rate. It should be 1 minus the true positive rate should be 1 minus the true positive rate should be 1 minus the false negative rate. Yeah, that's the calculation here. So instead of 99%, here we should have 97% as the accurate, because the remainder, that's the 3%, will be false negative.
That's where like Katie, I have the complete different process, like with like from yours, but I got the same answer.
Yeah.
But,
so here, what's important is making sure the position of the conditional probability, so what's being conditioned on, is in the correct position. So, on the first row, what we want is conditional on having COVID. What's the percentage or probability of testing positive? So once we get that right, so we know that this percentage or probability should be 1 minus the false negative rate, because a false negative rate is that when a person gets COVID, but it tested positive, test negative, right? So if we condition on a person gets COVID, then the probability of testing negative and testing positive should sum up to 1. Do you agree with me on this?
It is a little confusing right now. So is that what you mean, like Katie's chart? Because I look at this, Katie's chart has a major difference from mine is because the false positive was not supposed to be. So on the positive, which is means people who actually got COVID, right? So 7% people who got COVID. And if you're looking at the false negative 1%, so we supposed to put false negative 3% on this one instead. Is that correct? Because false negative, that means probability of people who test negative who have the COVID, right? So we have to put that 3% false negative on the positive rate up there, like 7%, because I don't use positive, I actually use COVID and non-COVID, so it's more clear. So I think maybe this is the confusing part at the Katie wants, because
all right. How about we work through this together? If I share the screen, so
Yeah, I'll stop sharing.
I can, let me see this. I can illustrate what those probabilities actually mean, so it helps us to understand based on what we should calculate. So first, let's understand some concepts, right? So the question gives us false positive rate and true positive rate. Sorry, false negative, right? False negative. So let's understand them correctly first. So a false positive rate is that when a person did not have COVID, but it tested COVID, right? So this probability would be written in this way. So if P, this means probability. So, wow, this is the largest I can get. So understand that this rate is a conditional probability. So known or given a person did not have COVID, then the probability of getting a positive test result is this much. That's what's called as false positive rate. Do you agree with me on this? Any questions here? Okay.
No, I just say yes. Yes, we agree. I agree.
All right. So now let's do the same for false negative. So based on the same rule, we know that false negative is when person actually has COVID. We're conditional on that. So if we already know a person has a COVID, what's the probability of having a negative result? So this is what a false negative rate means. Am I correct? Any questions here? Right. Oh, okay. Wonderful. So you know that a probability like this has a, these are called conditional probabilities. So immediately we would know that if we add this plus its complement, which is the rest of the probability, right? So what's the rest of this probability? Given a person has no COVID, there's only two possible results, right? Either positive or negative result. Are you with me here? So if we know the false positive rate here is how much? 1%, right? We know that the remainder should be 99%, but let's see what this remainder is. It should be negative test result because that's the only other possible result if a person has no COVID, right? So these two probabilities should sum to 1. So are you all with me here? Any questions so far? Okay, now very clear. Now let's do the same. So if we take the remainder of this, I mean, we need to find the complement of this probability. So given a person has COVID already, there are only two possible test results. If it's not negative test result, then it must be positive result, and their probabilities must sum up to 1. So that's positive test and conditional on the person has already got COVID. So that means false positive rate plus what do we call this if a person has no negative no COVID and conditional on that the test is also negative. This should be called what? Any hint? Any answer? So my question is, what do we call this probability shown as here?
Do you test positive, but you don't have COVID, Jerry? Is that what you're saying?
Yeah, no COVID, conditional on no COVID, a person still gets a negative result.
Sorry, no COVID, but they get negative?
Yeah, that's the highlighted part here.
So would it be probability of test negative, no COVID?
Yeah, so we, yeah, good answer. But we also call this true negative rate.
Oh, okay.
Right? Yeah, are you with me here? So as you can see,
Barely.
yeah, we do not add a false positive and true positive rate to find one, but we add true negative rate to become one. Are you with me here? So I'm basically translating the probability to the concepts or the terms that we already learned.
Yeah, I think so.
All right, then based on the same rule, we do the same thing here. Let's interpret this part. This conditional on a person with COVID, the percentage of getting a negative test result is what's known as the false negative rate, right? And what do we call this part? If a person has COVID and if a person has COVID, conditional on this probability, what's the chance of getting a positive test result? What do we call this probability?
This is true.
True positive.
Wonderful. So it's called the true positive rate. Then let's use this to fix what we built on before. So I saw that Katie had a wonderful workflow of all the different branches to go through, but we need to make sure to use the correct rates here. So if we are analyzing or breaking the breaking the COVID results, we need to make sure that they match these rules. So if we know the chance of the COVID, right? So then we can also find the probability of the negative or positive test in general by using the rule of the conditional probability. So this, let's find this first. If we already know the chance or the prevalence of the COVID, that's this statistic, how can we calculate this one? That's the false negative rate. So as the rule of conditional probability states, we know that to calculate such a conditional probability, we should first insert this COVID probability, then we calculate the probability of both. So that's the negative test and COVID. Are you with me here?
Yes, just the times together.
Yeah, so using this rule, then we can find the rest of the probabilities. So the important thing is that we find these rates correctly. So that means instead of multiplying 7% with 99%. That's not correct. We should multiply 7% with 97%.
Is that what the question asks? Because this is something I confused. Because
Yeah, this question actually asks the other probability. So it asks for this. Positive. If we get a positive result, conditional on this, what's the probability of actually getting COVID? So that's the accuracy of the test.
can you give me 1 second? Because I did exactly what you said, but when I read the question one more time, I just want to do the opposite way. So if somebody tests positive, and then what's the probability that infect COVID? So why would I not put a positive in the front and the COVID after? I actually did correct, but now I'm reading it, I'm just like, why is not positive first? Because it says if somebody tests positive and then he has possibility to infect with COVID, right?
I see. Okay, hold on. I guess that's why, probably because I made a mistake. Here, this is the correct one. So this is the intersection of these two things happening together. It's not a conditional probability. That's how we use conditional probability, like this part, conditional on COVID. Then we times the conditional probability on the probability of whatever is being conditioned. Then we get the unconditioned but the intersect event probability. So we use what's given as this and this to calculate these events. That help us to derive this probability.
Sorry, I still didn't get it. Give me 1 second. Okay, let me. I don't know if you guys.
No, I still lost.
Yeah, so we are at the time that, okay, so can you explain, so what's the question asked? So the question is, if the person tests positive, right? What is the probability that he or she is infected with COVID? So can you explain to me, like, why are we not putting positive in the front and the COVID in the back? And we actually do it.
Yeah, so we all learned something about conditional probability, right? So what's behind this vertical bar is what's being conditioned. That's given event. So we basically it's like an already happened stuff. So that means we do not consider the chances of a person getting negative results because we already know a person gets a positive result. We just want to find out how much percent of this event also coincide with actually getting COVID. So that's what conditional means here. So if we restate the question, given a person has a positive test result, then what's the probability of actually getting infected with COVID? So,
so it's
did
actually,
I make myself clear here?
So I think if you explain to that, it's very clear. Just like if your precondition is in the back, and then the one that is the probability that you want to resolve is actually you put in the front. So now it actually makes sense if that's, okay. Now we're using the Bayer.
Here, I'm just using some mathematical symbols, but I think it actually helps us to understand what these probability actually mean. Here, the question directly asks the probability conditional on a person gets a positive result this part behind the vertical bar is what's being conditioned. Then we think about what's the chance of actually getting COVID. So we translate it. So basically, this one is like what we learned. Well, I was hoping to make an equation. So because conditional probability is basically a ratio between some events, right? We just need to find the correct events. So here, what we want is that COVID and positive. So the position of these two things are not important here. If that's the same as positive and COVID. But what's important is what we need to divide it by. So here, because the conditional part is positive, so here it's actually straightforward. That's the probability of getting a positive result. So are you with me here? So we can also write probability in the beginning to stress them.
Hey, Jerry, what's the difference between COVID and positive versus positive?
Oh, COVID is the actual infection. Positive is test result.
Oh, okay.
So Jerry, what's the difference that you put and instead of that line,
Vertical
like
bar.
straight line?
Vertical bar indicates a conditional probability. So for example, here, the question asks, given a person, so we already know a person has a positive result. So for example, we go to a test center, we only find those people with positive test results. So it's not possible or irrelevant to study the situation among negative test results people, right? So given this condition, then how many out of 100 positive result people actually have COVID? So that's what this probability addresses. Do you agree with me here? So that's what a conditional probability refers to.
So can I understand when you're writing COVID and positive?
Yeah, here it's different. Here, the base population would be all people. It's not just the positive test result people.
Yeah, what I mean, like, because on the handout they're using, I think maybe you're ahead of time, like one step ahead. So what on the Bayer theorem, like there's
Bayesian theorem.
So it says theory. Anyways, so it's possibility of positive, whoever got COVID and it tested positive times the people who actually got a possibility that who got COVID, and then divided by the total of possibility of positive.
Yeah,
so you
it's
actually
the
get
same concept.
that's the same thing. Okay, I guess you.
Yeah.
And now I understand. So
Can you say that one more time?
So
It's the
do you all agree with what I wrote here? So that's
I can go back and watch the videos. It's not clicking, but I know we also want to do question number 3. So if everyone else gets it,
I know.
Go back and watch the recording.
Good catch. I was like, it's already 38. Yeah.
Yeah. So now it's quite straightforward to calculate the intersect of 2 events if they are uncorrelated, because getting COVID and test result are independent events, right? So here we basically All right. The remain, yes. So we need to calculate these two things separately. What's on the numerator and what's on the denominator. So for this, that's, as I illustrated here, we also use the conditional probability to get this intersection probability. And we add some of these intersections to get this positive, general positive percentage. So do you need me to go further with how to calculate these, or do you want to work on other questions? Yeah.
You really quick, like just because I got 69.3, which is actually exactly, I calculated differently, but I did exactly what Katie got.
No, unfortunately not the correct result. So as I said, you the reason is that you did not get these correct. So you need to time the correct rates instead of the other rate. So let's see. Let's work on this first. So if we already want to.
Sorry, so if you guys want to move on the question 3, I can pass it. It's fine because we all have question on the question 3. Yeah, if you guys want to pass it.
Yeah. Any other ideas, or do you want me to continue with this?
Let's move to 3. Yes, please.
Jerry, I mean, if you'd like, Jerry, I've got something worked up. I don't know if it's accurate, but it might help with explaining if it's correct.
Sure. Let's show it.
So I just watched, I think it was his 3rd of the 4th Bayes theorem videos that he puts together this table when he's talking about the HIV example.
Mm-hmm.
So I just watched that video and plugged in the numbers for COVID. And then to get the ratio, I believe you take this as the numerator, this 0.069679. Are you not seeing it?
No.
Whoops, hold on.
Make sure you click.
Yeah, I hit shared
the
screen.
Windows.
Hold on. Can you see the spreadsheet now?
I can. How about other students?
I cannot. Maybe there's option that I can see your. Oh yeah, we can because you guys both share. Yeah, I saw it.
Are we both sharing? Jerry and I are both
I
simultaneous.
Yeah, so we have to
I don't know
toggle
what
between.
happens if multiple people are sharing. Yeah.
Okay,
I
now
just turned off mine.
Okay. Is this visible for everybody?
Yes.
Okay. So I set up all the probabilities on the left-hand side, and then plugged them into this matrix. And then for COVID test positive at 0.0679, and then put that divided by this number here to create this new matrix to get the probability of if you test positive and you actually have COVID. Is this correct, Jerry? I mean, is this like on the right track or?
Yeah, looks correct.
Okay. So this is on the 3rd Bayes theorem video. He does this with the HIV example. He builds a table very similar, a matrix very similar to this, the professor.
So much.
Thank you. I'll
Yeah,
go look
so
at that.
the video might help. It's exactly the same concept as HIV. So what's important, as I said, do not, it's to understand what a false positive and false negative rate actually means. All right, let's move on to question 3. What are your questions like?
One more question on that note, Jerry. Do you think, is it likely we'll get a question like this on the quiz where we'll have to work the whole realm of probabilities out?
Yes, previously there were questions like this.
Okay, thank you.
Yeah, when I address these questions, it really helps me to get the correct results when I write the equations like I did. So I understand what each probability means. So I do not incorrectly multiply some concepts that are not related or not correct. All right. Since you worked on question 3 already, what's the questions like? We need to also calculate some probability of a hotel booking.
What? Yeah. Was this? This is a binomial distribution. Is that okay?
Yeah, you're correct on that.
So I use, at least for my attempt at it, I used his spreadsheet. I don't know if you guys can see my screen now.
Yes.
But I plugged in, number for 50. I put 54 rooms booked. Then the 3% chance that someone who booked a room would not show up as a probability. And then number 1. And then I thought this would be the answer. X is greater than 1, thinking at least one person doesn't show up, this would be the probability.
How about other students? What did you think about Stephen's answer? Did you find the same result or different ones?
I understand like at least one, you have to add the one that equal to 1, right? So add equal to 1 plus the X more than 1, greater than.
I see. So how about Stephen, can you continue sharing in your worksheet? Yeah, let's go from there. So I see. Can you click on the cell that's above it? Basically F10.
F10, yeah.
Yeah, so here that's how the binomial distribution probabilities are calculated. Notice that it's the cumulative probability that's calculated because we have a capitalized F as the function, right? So it means we are calculating the cumulative probability. But note that what this means here, as it shows, this probability means the probability of X being 1 or smaller than that. Oh, sorry. Okay. Wait. Interesting. Oh, okay. I see. That's because you plug X there. So that's why we know it doesn't look right. So if there's only one person booking the hotel, then it doesn't answer our question, because our question is that at least one person that booked the hotel but does not have an empty room, right? So that's what's being extra. So any ideas how we can fix here?
Do we need to like find the probability for the 50 rooms?
Yes, correct. So notice that here on the spreadsheet, what we're calculating is the distribution of people, right? It doesn't really consider rooms. So, but to answer the question, we need to understand the relationship between the number of people booking the hotel and the number of hotel rooms the hotel has. These are two different things. So if we want to find that at least one person does not have a room, that means all the 50 rooms are booked. Do you all agree?
Yes.
Yeah.
Yeah. No, excellent. So that means the probability we want to calculate is that X is 50 or greater. Wait, actually greater than 50. So that makes at least one person remaining.
So it'd be
Okay, so-
How
51.
about now? So note that here, all the X represents people, the number of people, right? It doesn't mean the number of hotel rooms. So if we want to find out the chance of at least one person, right? At least one,
Okay.
to have an empty, to not have an empty room. That means all the 50 rooms are booked. That also means there are already 50 people
Right.
booking the hotel. So if we have a 51st person booking the hotel, then that makes this extra person, right? But there are also other cases when it's, even, 100 or, 200 people booking the same hotel, then it's the same condition. So we basically want to find out the probability of X greater than 50.
Okay. So is value for X 50 or is value N 50?
What do you think?
The way you stated it, it sounds like X is 50.
So let's do it.
But the way the professor's video talks about with like widgets not working out, he put it the number of whatever the item is in the N.
Mhm.
So then, okay, so here's X is 50. Then for N, is it one for one person or?
The N should be like this. So you got that correct.
Okay, so the N should be
However-
54.
Oh, I see. You also, no, because the P, the probability is not correct here.
Oh, okay. Is it
So, right?
0.97?
Yeah. Yes, because what we want to present is the
Ah.
success rate, is not the failure rate.
Okay. That's okay. That makes sense. Is that looking like we're in the ballpark?
Yeah. How about other students?
Okay.
Do you all follow here? So basically, that means among the 54 people, right? That booking, we have 50 successfully booked and the remaining 4 not booked. So what do you think here? Do we need to take the capitalized fx or the 1 minus fx as the probability
Seems
to
like
answer the question?
It seems like it'd be 1 minus the 92%.
Is it this, you're asking if it's this value or this value?
Mhm.
Katie, you think
'Cause
it's this one?
Well, if it's more than, if it's X is equal to more than 50, that would represent the one extra person. So, and if this is the success rate, and we need to calculate the non-successful rate, it would be 1 minus 92 or
Mhm.
0.92. So it'd be 8%.
However, to just clarify some concepts, these are not success rates though. The success rate here is the 0.97. When we calculate the cumulative probability, it's no longer the success rate. Great, so if we already understood the first one, I guess it's straightforward to go along with the following parts in problem 3.
So are you saying then that the rate is 92% for over? So
Oh, sorry,
I was
it's
gonna
not
put
the
this-
rate, it's the chance or probability. Yeah.
So if I were to, if I had to say this in, it would be the probability of one more person booking and being turned away is 92%.
Mhm. Because
Okay.
here, as it shows, this 92% is the chance of observing an X greater than 50, right? Being greater, it means it includes X equal to 51, 52, 53, and 54. Because X can only take integer values up to 54.
Okay, let's work on that next question too.
So
Gracious.
have you already got some work for part B, or are you referring
Yeah, it's for
to
sure
problem
wrong.
4?
You're talking about, Katie, you're asking about part B?
Yeah.
Okay. Same, yeah, I for sure did it wrong.
So any ideas how you may want to fix it at this moment?
So, because we want to see if, we want to know now the probability of 48 people showing up. Right,
Alright.
so would it, go ahead, sorry.
48. Question B is, let's assume 54 rooms have been booked. What is the probability that the hotel will have at least 2 empty rooms?
Mhm.
Oh, I see what you're saying. Ooh, okay.
So is it as simple as changing X value to 48?
Yes, however, we still need to find the correct probability to report.
Okay.
What do you think among these different stuff? What do we want to put for B? Which one?
So it's saying it's at least 2 empty rooms, right? So would it be X is less than or equal to 48?
Yeah, wonderful.
Okay.
How about other students? Do you all agree here?
I'm looking at my.
Sorry, I'm lost at 48. Can you repeat one more time, Stephen?
Um,
We have
Or
48 because it's there's 54 rooms, or it's 50 rooms. So if there's 2 empty rooms, there's what's the probability of 48 people show up? Yeah,
I see. Thank you.
no problem.
Great explanation. So note here that the probability is about at least 2 empty rooms, right? So that means the people coming into the hotel should be 48 or less. So if we have 47 people that, coming into the hotel, then we have 3 empty rooms. That also fits the condition requested by the problem. So here, that's why we need to calculate the probability of X being equal or less than 48. And it's the still same concept for X. That means the people actually coming into the hotel.
So it's X less and 48, the middle one.
Mhm.
It's like 0.5%.
I know. We can't calculate without this Excel.
Yeah.
It's still possible, but
It's easier.
yeah, this makes things easier.
For part C, Jerry, is it asking the probability of 54 people showing up?
For part C, was it your question?
Yes.
No.
Okay.
It's not a probability, but we also need to calculate the money, right, to pay
Right.
for. So we need to calculate probability for a few different occasions.
Okay. So would it be, is it 4 different occasions?
Great, you got that right.
It's like, wouldn't 51 be an occasion? If one
Yes.
person gets turned away,
Mhm.
and then it would be, would it be this value? X is, or
No,
the middle value? Less than or equal to?
it's not that either.
Okay. Equal, is it just equals 51?
Yes, you got that
Man,
right.
I was like, well, there's 3 options. Okay.
Yeah.
Okay.
So because we want to calculate individual probabilities here, the
Right.
reason is the money issued at different overbooking is also different. So we want to adjust for that. That's why we need to calculate individual probabilities for
So
discrete amount of
what
people.
when you get the value, is it then times $100? And you do that
Yes.
for each value and add the values together?
Yes, that's
Okay.
this is a typical case for calculating the expected value of discrete variables.
Okay. Okay, thank you.
So it'd be like, if I'm hearing this right, it's X is 51 and then 52 and then 53 and 54.
Yeah.
So you do
right.
it for each one and then you add them together to understand the probability for each one.
Mm-hmm. Right. What Stephen is writing here is how to calculate the expected value of a discrete variable. So basically, we time the probability of each individual or discrete value with the value itself. However, as some of you might have noticed, the money as voucher is incorrect here, because if we have 2 customers turned away, the hotel would have to pay $200, right? Because each would receive 100. If there are if 4 customers were turned away, then the hotel would pay 400.
Thank you for that, Jerry.
Thank you so much. I finally got what you said.
Wonderful. So I guess if you, yeah, thank you for Stephen.
Yeah, no problem.
Mentioning the video resource and also sharing with his work. If you still run into questions about problem 2, I suggest you to rewatch the video. But what's really important is understand what the false positive and false negative rate actually means, and what's the remainder actually means. As I illustrated earlier, the if we know the false positive rate is 1%, the remainder 99% is the true negative rate. So it's important to understand these parts. But I guess if you want a rule here, you need to flip 2 or both of the indicators. So if we know 1% is the false positive, then we flip false to true and flip positive to negative. Then we know the true negative rate is 1 minus 1%. I guess this helps understand the concept. All right. Thank
Thanks,
you for
Jerry.
spending the time with me. And
Last question.
oh, okay.
I got one more too, Jerry. Go ahead, Alyssa. If that's okay, Jerry.
Oh yeah. Oh, I'm sorry.
I said, go ahead, Alyssa. Sorry to interrupt.
No, because I saw your answer. It was on the problem 4B. I was a little different. I'm just wondering, like, I have the same thing with you, like the first one, like what we exactly we're looking for, the X equal greater than 4 and equal less than 5, right? But the equation you did, is that including the X equal to 4? Because you actually is already minus it. Because you minus X equal and the less than 4. So where's the X equal to 4? Did I get this wrong, or?
I got the same answer
You got the same answer?
as Stephen, yeah. Because I
Okay.
scrolled down and I used the normal distribution.
Yeah, I used that one. I'm just wondering, like, because when we doing the X did I actually understand this wrong? So when you're using greater equal to 5 minus less than and equal to 4, so we missed that 4, right?
Oh, I see. So it seems Ziyu's question was actually about whether to add the equal sign or not. Am I correct?
Yeah.
So first, it actually doesn't matter. That's because this probability density curve is basically a frequency chart, right? Except that it has infinite number of breaks or the bins. So that also gives a probability saying that here, if we actually calculate the probability of x equal to 4, for example, it'll be 0.
Oh, I see.
So
That's
it won't matter whether we include the equal sign or not when we calculate the probability, for example, for this x smaller or equal to 4. If we replace it by x smaller than 4 without considering the occasion of x equal to 4, it'll be the same probability.
okay, I understand now. So, but if you want to make it more accurate, is it supposed to be not adding the equal sign?
No, it doesn't have
It doesn't
anything to
matter.
do with being
Okay.
more accurate or not. As I
Okay.
said, if we calculate the probability for normal distribution, right? X equal to 4, for example, it'll be 0.
Okay.
Yeah.
Yeah.
It'll be
You.
the
yeah.
same if we calculate the probability of x equal to any specific value, it'll be all 0.
Okay.
So that's why to calculate these probabilities, we always calculate the probability for a region instead of a single value.
Mm-hmm. I now I get it. So we don't have to worry about like exact numbers on it. It's just a area, like okay, a range. Okay.
Yeah.
Thank you so much. Thank you, everyone. That's very helpful.
Thank you, Jerry. So does this look accurate to you, Jerry? Because I was going back and forth on which values to pull from the statistics sheet.
Are you asking about problem 4?
Yes, sorry, problem 4, part B.
Yeah, it looks correct.
Okay.
Yeah, you wrote the equations nicely.
Thank you.
That's perfect. That also helps me understand how you got the probabilities.
Okay.
So yeah, you went
Okay.
a
Thank you.
very good way to address this problem.
You were very helpful tonight, Jerry. This was a very hard week for this class.
Oh,
Yeah, I'm wondering if we can just go over problem 1 real quick and make sure. I think all the problems did not end up how I expected. Well, except for number 4, but number 2 was such a side. I don't know. Review number 1. From how I'm understanding the question is that it would mean this means that 5% of the tests come back negative or incorrect. They should be positive. And so said another way, the person tests negative for COVID and there's a 5% chance they have COVID. And I said, yes, we want that information so that we know that the data is not always true. And it would be helpful to also know how many tests come back negative. Then we can tell the overall picture. We could say that the probability of having COVID and testing negative is X%.
yeah, it sounds fine, except that I didn't hear whether you interpret the false negative rate correctly or not.
So can I try my?
Yeah.
I got a different one, but So I got like, I say 5% of false negative rate means the probability of people who test negative and actually had COVID. Is that correct?
No,
False negative.
fortunately not.
You know, that's why I every time doing homework, I will have like every problem, I have different answer for. Okay.
Yeah, so as I showed earlier, I think the best way to understand it is if we write the concept explicitly out. So let me redo it here. False negative rate, right? That's a person already have COVID. So we only, the base population or the surveyed people here are only people who actually have COVID. So whatever happened to people that do not have COVID won't matter. So among these small, portion of the population, what's the chance of getting a negative result? That's what a false negative rate means.
False negative, that means if a person actually already have the COVID, but it get tested as negative, is that correct?
Yes.
So what I said is not
But
right.
do make sure to interpret the conditional probability right. So this does not mean the chance among all people, the proportion of people with negative result and also actually got COVID. We need to find the relevant portion of the population to refer to. So here we would specify or shrink or only focus on people that already have COVID.
Okay, so
Okay.
is this okay? So this is who have COVID, who actually have COVID, but actually got test negative, right? So, but this is not the numbers we want though, right? We want to know the accuracy of the COVID test, right?
Yeah, something like that.
So we want to know who actually who tested positive, actually having the COVID, right?
Yeah, that's why, or that's what we are addressing in problem 2.
Okay, so both are right. It's just, so both
what do you mean by both are right?
mine and the kitty, I think, got complete different ones.
Oh, I missed the part when Katie interpreted her interpretation or other concepts. So did you mean that each of you brought a different probability that's more relevant?
Yeah, I think Katie, I don't know if I overheard because I heard you were focused on negative. The result.
Oh, I see. Yeah. So what's easier or more important to understand is conditional having these quality are
Oh, I see.
both important.
Okay, I see.
Yeah. From what I'm hearing, I'm saying the survey of people who have COVID. So this 5%, the false negative rate is 5%. So that means it's the survey of people who have COVID have a 5% chance that the test shows negative. And we want to know the information, but it would also, because the data is not always true, or the test is not always true. And it would be helpful to know how many people were tested and the people who have COVID who test with a true positive. Right. So we also want to know how accurate the test is.
That's the goal. Wonderful. I see that you're on the great track.
Ooh, thank you.
Thank you so much. Sorry.
Thanks, Jerry. This
Like,
is
Yeah, I guess. Yeah, maybe you need to rewatch part of the video where it explains this test and disease 2x2 table again.
okay, thank you so much.
Thanks, Jerry.
Thanks,
Thanks,
Jerry. This and
very
Jerry,
nice.
this number one's not asking for a quantitative answer, correct? It's just asking more qualitative of what we,
Yes,
what our
you're
interpretation
right.
is and what we want to see.
Yeah,
Okay.
but it's really important to understand the concept.
Right.
Yeah, for example, in problem 2, we immediately see that 1 minus false negative rate is not what some students thought. It must be the true positive rate. So it's important to get these things correct.
Gotcha. Okay.
Yeah.
Thank you.
Thank you so much,
Thanks for
Jerry.
staying long tonight.
Everybody.
Thank you. Have
Thank
a
you,
great
guys.
night.
Well,
Bye,
glad
guys.
it helped. Bye-bye.
Bye.